The Lambda Annotations Framework is a programming model that makes it easier to build AWS Lambda Functions. The framework uses C# custom attributes and source generators to translate annotated Lambda functions to the regular Lambda programming language. In a previous video, we learned how to get started using the Lambda Annotations Framework and how it compares to building APIs using the default Lambda programming model. With the Annotations Framework, we were able to remove a lot of boilerplate code that was required to connect with API Gateway. I highly recommend checking out that video, which will be linked here and also in the descriptions below if you're new to the Annotations Framework. In this video, let's see how we can use the Lambda Annotations Framework to build a CRUD API, an API that you can use to create, read, update, and delete items from a database. We will be using DynamoDB as our database, but you can use any other data store that you wish. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud, and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Switching over to Visual Studio, here I have an existing solution open which I used in the previous Lambda Annotations Framework video. Here I have two projects inside this solution, which is the Lambda Annotations sample.before annotations and also the one that we built from scratch. Now this is the one that compares to building the API using the normal Lambda programming model, and the from scratch project has the one where we built up the API model from the scratch using Annotations Framework. Let's add a new project inside here to create the CRUD API. So let's right click and say add project. Let's select an empty project like before. So let's use the AWS Lambda empty project. Click next. Let's name this as Lambda Annotation Sample.order API. So we will be building a CRUD API to manage orders in a system. Click create. Let's choose the empty function and click finish. Now this is going to create an empty Lambda project. So if we navigate into the function.cs, we can see the default function handler. Now to start using the annotations framework, we need to add NuGet packages as we saw in the previous video. So let's right click and say manage NuGet packages and browse for the packages. Let's search for Lambda annotation. Let's add the amazon.lambda.annotations package into this project. Let's also search for the API Gateway Lambda events NuGet package. So let's add this one into this project as well. And since we need to talk to DynamoDB, let's also add the DynamoDB package. So let's choose the AWS SDK.DynamoDB v2. So once these three packages are installed, let's switch over to the function.cs and let's add our first API endpoint. Now since we need to do a CRUD API, let's start with the create, which is going to be the post endpoint. So let's remove this comment. Let's annotate with the Lambda function attribute like we saw in the previous video on how to set up a Lambda function. So this marks that function handler as a Lambda function using the annotations framework. Adding this has immediately created the serverless.template file, which is the CloudFormation output to deploy this Lambda function. So you can see here, this is already having this function that is annotated with the Lambda function attribute. Let's make this as an HTTP API endpoint. In this case, we need this to be a post. So let's choose the Lambda method post, and let's also specify the path for this particular endpoint. So let's say order. Now in this case, we don't need to return anything because this is just going to create an item. So let's make this as a task return. Now, since we need to talk to DynamoDB inside our handler, let's create an instance of the DynamoDB context in the constructor. Then let's create the constructor for this function. Let's specify underscore DynamoDB context is equal to new DynamoDB context. Now this takes in a DynamoDB client, so let's create a new instance of DynamoDB client. Now this needs to be instantiated, so let's set up a field inside this class so that we can use this. And this is also marked as read-only. Now if you want to use an interface to hold this object, you can navigate to DynamoDB context. You can find out the type for this, and this is iDynamoDB context. So let's come back and let's use the iDynamoDB context as the type for this class level variable. Let's make sure to use the DynamoDB context to input an order. However, we need an order object for that. So let's create a new order class to hold the order details. So let's call this as order. Let's add a few properties to this. So let's specify a string identifier, and let's specify this as order ID. Let's also specify an order total for this. So let's specify a decimal and specify total. Let's also add in a date time just for reference. So let's say created date. Now this class might have more properties like the products in an order, individual items, quantities, etc. So let's start working with these basic information and start entering this item into the DynamoDB database. So let's switch back to the function class. Now instead of taking a string input, we're going to take the order as the input. So let's make this as order. Now in this case, since this is a post endpoint, I need to take this order from the body of the request. So I can attribute it just like we attribute in ASP.NET Core APIs. We can specify from body. Now this again is going to come from the annotations API gateway namespace. So once we have the order, we can insert this into DynamoDB context. So we can use the DynamoDB context.saveAsync and pass in the order that we have and call an await on this. Now I'll have to make sure that the order class is public so that I can use this in the API. So let's make that public. Since we've used the await, let's make sure to make the function handler as async. So once we add that, we have the complete endpoint required to post orders using the Lambda Annotations Framework. Our function handlers are much cleaner and removes all the boilerplate code that's required to interact with the API gateway. Now if I switch over to the serverless.template file, you can see the CloudFormation template for this handler. It sets up the HTTP API, sets it up as a post method, and also sets up the path for this gateway endpoint. Now, as part of this template, we also need the DynamoDB table and also set up the permission for this Lambda function to talk to this DynamoDB table. So let's collapse this. Under the resources, let's copy and paste the required CloudFormation template to create the DynamoDB table with the order ID as the primary key, and also specify the IAM role to set up this Lambda function to talk to this particular DynamoDB table that we are going to create. So let me copy and paste, and I'll walk you through this CloudFormation template. Now inside the order table, if I expand this, you can see this is a DynamoDB table type, and it sets up the attribute definitions and creates the order ID as one of the attribute. It also sets up the key schema and sets up the order ID as the hash key. This key table has only one key. It does not have the range key. I also set up the table name as order and set up the billing mode as pay per request. Now there's much more properties that you can control when you create the DynamoDB table. However, I'm keeping things to a minimum. So once we have the DynamoDB table, we also need to set up the IAM permissions for the Lambda function to be able to talk to the DynamoDB table. So let's collapse this and let's expand the IAM role. Now this, as expected, is a type of IAM role, and it sets up the required properties on it. So it sets that this is on the lambda.amazonaws.com. It also specifies the managed policy ARNs to use, which is the AWS Lambda basic execution role. This gives it permission to write to CloudWatch logs. In addition to that, we are also setting up an explicit policy by the name Order API DynamoDB Access Policy. Now this is setting up the permissions to talk to the DynamoDB table. So this gives all the DynamoDB actions on this specific table. So I'm getting the ARN using the function getAttribute from the order table in this CloudFormation. So you can see this order table is the same name I have used to define the order table. Now if this was different, the CloudFormation template will show an error because of the IntelliSense in this IDE. So let's make sure this is correct so that this sets it up as expected. Now that we have set up this execution role, we need to assign this role to the Lambda function. So let's copy this role name. I don't want to modify the generated code inside here, which will be replaced again the next time we make a change to the function class. So instead of specifying the role inside this generated code manually, I'm specifying this inside the function and going to specify it on the Lambda function attribute. So let's specify role is equal to and specify the @ symbol to say that this name is coming from the CloudFormation template. And let's use the name orders API Lambda execution role. Now the next time I save this function, the serverless.template will be regenerated, but it will not modify any of the resources that I have explicitly added in. However, if you expand the generated code, you can see inside here that it has applied a specific role to this Lambda function, which is again using the same function getAttribute and specifying the name orders API Lambda execution role, which is the role that we have created here. Now once that is all set up, we can deploy this to the AWS Lambda and see this in action. So let's open the Solution Explorer, right-click and say Publish to AWS Lambda. Now this asks for a stack name, so let's specify order and let's publish this to the order stack. Now this has started creating the stack, so let's switch over to the AWS console. I have the stacks open, so you can refresh this and you can see the order stack creation has already started. So if I navigate into here, you can also see the events that is happening as part of this creation. You can also follow this along in the Visual Studio IDE, where you can refresh this and see the status inside this. So you can see that the order table is now created and it is creating the execution role, and then it will create the Lambda function and the API gateway as well. I have fast forwarded in time using the magic of video editing, and this all process is complete. Now if I switch back to the stacks and refresh this, you can also see that this is complete in here. So let's go into the resources. And you can see the different resources that's created as part of this stack. So if I navigate into the HTTP API and if I go into the routes, you can see there is an endpoint for the post endpoint that we just created. Now one thing I had to make sure for this to work correctly is that I don't have a leading slash inside the route name here. Now if I specified a leading slash, for some reason the endpoint route was not getting created. So make sure you don't have a leading slash inside the template path. Switching back, we have the post endpoint. So if I click that, you can click configure to see the configuration where it is integrated with the Lambda function that it created. Now this Lambda function is the post endpoint function. You can see this is also part of our stack. Now it is named appropriately using the function handler as the name, because that is exactly the name that we chose inside the functions method. Now if you want, you can make this as post order, and the next time you deploy this, it will update the name. So let's switch back. Let's navigate to the API gateway. Let's go to the stages and the default stage. So let's copy the URL for this API. So let's copy this. Let's open the tool Postman so that I can make HTTP request using the editor. So let's click the plus and create a new request. In this case, I'm using a post. Let's paste in the URL that we copied and let's specify /order endpoint. Now I need a body inside here. This is going to be raw and it's going to be in the JSON format. Inside the body, I need to specify the order data. So let's copy and paste that. And here I have the order ID, the total, and the created property. Now for the order ID, I'm randomly generating a GUID. The total is 100.2, and for the created, I'm using the ISO timestamp. This is a way to specify inbuilt variables inside Postman. So once I've specified that, let's click send. This is going to make a request to the API endpoint, and it's going to come back with a response. In this case, it specifies 200 OK. Now, if this was not a valid integer, this is going to return us an error. So you can see this is an invalid number and it cannot be used. So this is returning a validation error on this API endpoint. However, we were able to insert the first item. So let's navigate over to the DynamoDB table that was created as part of this stack. So let's go to the order table. Let's use explore table items and you can see the first item that we created here. Now let's go back to our function and add the get endpoint to get this item back. So let's switch over to Visual Studio. Let's use the Lambda function attribute to specify the Lambda function. Now in this case as well, we need the exact same role. So let's copy and paste this inside the attribute code. Let's specify the HTTP API. In this case, this is going to be a get method. So let's specify get and let's specify the route as /order/ pass in the order ID. So let's pass this as a path parameter using the order ID variable in here. Now this is going to be a public async. Now since this is going to return an order, let's specify task of order and let's specify get order method. Now since the order ID is part and it is string, let's use order ID as the string input. In this case, you can also take the Lambda context and specify context. Now, once we have the ID, we can use the DynamoDB context.loadAsync method, specify the order table, and also pass in the order ID. And let's return this data. Now, in this case, it automatically uses the table name that is from the type name. We saw that in my DynamoDB video and how the conventions work for DynamoDB. Check that out, which will be linked here and also in the descriptions below. Now, once we have added this method, if I switch over to the serverless template, you can see the resources that I manually added still exist, and it has also added a new Lambda function. So you can see there is a function getOrderGenerated. Now this has the properties as we expected, and it also sets up the role as we specified. Now let's right click and deploy this again. So let's right click and specify publish to AWS Lambda to the order stack, and let's click publish. Now this again updates the stack, so you can wait on this screen where you can see the progress of updating the stack. In this case, it has to create a new Lambda function and also update our older Lambda function name, since we made that as post order. Let's go to the stack and let's refresh this. Here you can see it's already created the Lambda function getOrder, and it's also updated the function name as post order. Now once the update is complete, let's navigate back to our API gateway and let's refresh on the routes. And you can see there is a new endpoint automatically added here, which is the get endpoint. So let's go back to our items. Let's copy this ID and let's switch over to Postman and create a new get request. So let's copy this URL from here, paste it inside the get request URL, and let's also specify the order ID. So I'm using the Windows V clipboard manager and selecting it from my copied list. And let's click send. Now this is going to make the request to the API gateway, hit the Lambda function, and return back the data from DynamoDB. So we are successfully able to retrieve the item from DynamoDB. To update in DynamoDB, we can use the same post with the different values. So instead of using the $GUID, I can pass in the copied GUID that I have so that it updates the specific item in there. And let's also specify the value to be 99. And let's click send. Now this is going to update the item inside the database for this exact same GUID. So let's switch back into the database. Let's click run. And you can see the total here is updated as 99. The next time I fetch the data, that is also going to be shown as 99. We have done with the create, read, and update. So let's switch over to Visual Studio and implement the last one, which is the delete functionality. So let's copy this function. Let's paste this in here and let's specify the delete instead of the get. Now it can use the exact same route because it also needs the ID to delete. So in this delete, we don't need to return anything. So let's remove that. And instead of get order, let's name this as delete order. Now instead of calling the load async, we're going to specify the delete async, pass in the type order, and also specify the order ID to be deleted. Now since there's nothing to return, let's remove that. Now once we have that set up, if you switch over to the serverless.template, you can see one more function being generated, which is for the delete endpoint. So that is all set up as expected. So let's deploy this, choose the stack name and click publish, and it's going to deploy the new delete endpoint that we have just added. The stack update is complete. So if I switch over to the API gateway, so let's refresh this, and you can also see the delete as part of this route. So if I go over to the Postman, let's copy this exact same URL, create a new tab, choose this as delete and paste in the URL, and let's click send. Now this has successfully deleted the item. So if I switch over to DynamoDB and run this again, there are no items inside our table. So we have successfully implemented a CRUD API using the Annotations Framework. If you look at the code, it's very minimal and clear to follow. You can see the Annotation Framework hides away all the boilerplate code under these two attributes. It's made us easy for developers to focus just on the code that we need to write. So if I build this project and navigate to the bin folder of this order API, so let's specify open folder in File Explorer. Let's go to the bin folder, the debug, and let's explore this DLL. So let's use .peek, which is a tool from JetBrains. So we have .peek open. So let's drag and drop the order API DLL into here. So let's expand this and we can see the different classes inside this namespace. So you can see we have the function class and we also have 3 other generated classes. Now these generated classes is what is getting referred inside the serverless template. So if you look at the serverless template, you can see it is referring to the generated class and the delete order function inside that. Similarly for the post and the get methods, you can see the delete function inside here is wrapping around the actual function code with the boilerplate code generated. So you can see it's taking in the input from here as the API gateway proxy request, getting the data from the path parameters, doing all the validation for us, and if it all passes, it finally calls the actual function's delete order passing in the order ID. So all this boilerplate code which we would have otherwise written is now handled by the annotations framework. This is exactly the same in the case of the get order and also the post order request. I hope this helps you to implement a CRUD API using the Lambda Annotations Framework. We saw how easy it is to use the Lambda Annotations Framework compared to previous ways of building APIs. A lot of the boilerplate code is hidden by the annotations framework. It also enables us to focus on the business logic alone and write the functions very easily. We saw how to connect with DynamoDB and also set up custom resources in the generated serverless.template file. Anything that we have added explicitly doesn't get removed when the new file is generated automatically as we change the code. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.